Capable of eye-catching gymnastic feats, lightning-quick machine learning, and slick dance floor bops, Boston Dynamics robots are truly a modern-day technological marvel. And whether you think they mark the dawn of a new age of idle leisure for mankind, or represent a grim harbinger of humanity's inevitable enslavement, you must admit they're pretty cool from an engineering standpoint. So today, we're peering under the hood of our future metallic overlords and finding out just how Boston Dynamics build their robots. The most striking feature of Boston Dynamics' more famous latter-day creations, the adorable dog-like Spot and the swole Stormtrooper-esque humanoid Atlas, is that they walk on legs. Boston Dynamics' decision to go down the route of legs instead of wheels or caterpillar tracks was taken early on in the genesis of the company. Its founder and chairman, Mark Raybert, was for many years an academic, serving as Professor of Electrical Engineering and Computer Science at MIT and Associate Professor of Computer Science and Robotics at Carnegie Mellon University. It was around this time in 1980 that Raybert founded the influential so-called leg laboratory, and in doing so made a crucial early stand for this tricky means of locomotion. Why? Wheeled robots are only useful on flat, smooth surfaces. They don't handle stairs very well, to say nothing of coping in the kind of complex, unpredictable natural environments robots would ultimately be expected to work in. Legs, to be sure, are a lot more challenging to build, necessitating a complex interplay of software and hardware engineering. But as Boston Dynamics' always entertaining videos demonstrate, there's really nothing like legs when it comes to versatility, strength, and sheer style. Let's look at the software involved first. When most people talk about robot software these days, the subject of AI, artificial intelligence, usually crops up. But Boston Dynamics take a subtly different approach, emphasizing instead what they call athletic intelligence. Athletic intelligence refers to the automatic, almost subconscious processing most of our brains perform whenever we move, whether that's bounding up a staircase at home or sprinting for the bus. Those countless tiny computations we perform without thinking just to stay upright represent a colossal challenge for Boston Dynamics bots. In order to acquire athletic intelligence, the robots first need to be equipped with a means of assessing the terrain in front of them. In the case of Atlas, clever LiDAR sensors, basically radar but using light, do the job. Spot, for its part, uses more conventional cameras alongside sophisticated 3D sensors. Once the terrain ahead, say a staircase, is identified and mapped, the compact robot brain is able to search through a vast internal trajectory library, stocked with both the robot's own prior experience and presets acquired from earlier staircases tackled by different robots back in the lab. In Spot's case, experience has taught it to go downstairs backwards, in the name of greater overall stability. Atlas has special pressure-sensitive feet, which can detect squidgy or unstable terrain, helping the robot finally alter its balance and gait accordingly. The appropriate trajectory on its onboard library is followed as closely as possible, with real-time considerations like balance and underfoot conditions factored in using sophisticated algorithms. On the hardware side, Boston Dynamics robots perform their deft physical tricks thanks to a finely calibrated network of internal hydraulics. On earlier iterations of robots, this hydraulic fluid was pumped around the body through bolt-on tubes. But engineers at Boston Dynamics' Waltham, Massachusetts headquarters figured out they could make their components quicker, lighter, and more reliable by 3D printing robot body parts with hydraulic channels baked in. So a leg, for example, will carry hydraulic fluid within its very bones instead of relying on cluttered additional piping. Parts that would previously have been prohibitively complex and expensive to manufacture at scale, for instance the 18-port hydraulic manifold at the heart of Atlas's locomotive system, are printed, tested, and modified in Boston Dynamics' lab with all hydraulics embedded as standard. Similarly, the all-important servo valves, which help all 28 joints across the arms and legs of Atlas stay supple and ultra-responsive, are made in-house at Boston Dynamics. This makes the process of iteration and improvement cheaper and quicker. For now, anyway, the humanoid Atlas robot is a strictly R&D only project for Boston Dynamics. It's there to push the boundaries of robotics and make fun videos, and that's about it. Spot, on the other hand, is Boston Dynamics' first robot intended for proper commercial rollout. As such, its design philosophy is a little bit different. Much of Spot's functionality comes available as standard. So thanks to its 12 custom-built DC motors, each specifically geared down to provide high torque, Spot can walk, climb stairs, avoid obstacles, navigate challenging terrain, and autonomously follow preset routes out of the box without needing constant input from users. But ingeniously, for future commercial applications, Spot can also be upgraded and modified. A prehensile arm with primitive hand can be attached to one of two so-called payload ports on the robot. More subtle adaptations, such as an automatic command to pause working when a person is nearby, can be added at request. Mark Raybert has suggested his ultimate dream is for Spot to become a platform for other developers and industrial users to make their own distinctive mark on. As he drolly puts it, he'd love Spot to be the Android of robotics. For now, Boston Dynamics works closely with its customers in ascertaining how best to integrate Spot into diverse working environments, for example oil rigs or shipyards. Partly, this after-sales care justifies Spot's lofty $74,500 price tag. But it's also so Boston Dynamics can lead by example and create a brand new market for their products while they're at it. The commercial side of Boston Dynamics is a fascinating study in itself. Few companies have the luxury this Massachusetts outfit enjoys, on the surface anyway, of open-ended R&D wheezes like Atlas. But it's not that simple. Atlas was originally created using funding and oversight from the US Defense Advanced Research Projects Agency, or DARPA. This military backing obviously helped advance the progress of robotics, but quite fairly gave many observers pause, especially those of us who fret about the inevitable android insurrection happening any day now. As it happens, Boston Dynamics' main project for the US government was a larger version of Spot, known as Big Dog, intended for service as a pack mule in war zones. Big Dog was sadly discontinued in 2015 after military top brass decided its gas-powered engine was simply too noisy for active duty. Boston Dynamics has since changed hands a few times, owned at various points by Google parent company Alphabet, who sold the firm in 2017 to Japanese investment conglomerate SoftBank. SoftBank were considered a tidy match by some commentators, especially those who were eager to see Boston Dynamics emerge from the lab and begin full-scale commercial rollouts. Alas, it was not to be, despite Spot enjoying limited rollout across select commercial and industrial settings. London architecture firm Foster & Partners, for instance, used Spot for real-time construction monitoring on its high-profile Battersea Power Station redevelopment. Elon Musk's SpaceX hired a lone Spot named Zeus to help inspect dangerous sites around the launch pad at its Boca Chica Starship test site situated in South Texas. As of December 2020, SoftBank is handing the reins of the company over to the South Korean auto giant Hyundai, whose ability to manufacture at scale will hopefully bring Boston Dynamics robots into the mainstream. For now, though, Mark Raybert and his team will continue working in the lab and racking up those patents, such as the one awarded for its clever in-house designed actuator system, which enables the lightning bursts of strength seen in those famous Atlas somersaults. And even though it's not quite yet a commercial powerhouse, Spot is enjoying countless fun applications, from performing as a cheerleader at a Japanese baseball game to workshopping dance routines with Cirque du Soleil. In Singapore, Spot has even been seen out on the streets, helpfully aiding pedestrians to adhere to social distancing rules during the COVID-19 pandemic. So who knows? Perhaps the robot takeover won't be such a bad thing after all. What's your favourite Boston Dynamics robot? Are they creepy or inspiring?